Good morning all. So this is the sixth lecture of basic electronics engineering, and in the last lecture or in last few lectures I can say we have done number systems and conversions of number systems from one base to another base. Today we'll discuss the mathematical operations, addition, subtraction, multiplication and of course division of the number system with different bases, or I can say in general I'll start with, suppose I take this as, I name it as addition of, let's name it as non-decimal number system, non-decimal number system. Decimal number system we already know how to add it. So before I come to the addition of non-decimal number system, for example octal addition, hexadecimal addition, binary addition and all these things, let's recall what you studied in your childhood, early childhood, in your school days, how you add two numbers. First of all, that is, suppose I say that I have a number is given to you, suppose it is a 63, and suppose I say add 12 to this. These are decimal numbers, simple addition, simple numbers. It is 3 plus 2 is 5 and 6 plus 1 is 7. It is as simple as it is. Now suppose I take another number, suppose I say that you add number say 47 plus 98. How you add this? This is base 10 and this is also base 10. Normal numbers that we know right from our childhood. 8 plus 7 is 15, carry 1, then 9 plus 4 is 13 and 1 14. This is the corresponding number in base 10. Now just try to understand the concept from this basic addition that we already know. Actually what is there? See, in this first problem, we know that in decimal numbers we have digits from 0 to 9. In decimal numbers we have digits from 0 to 9. Now, if the result of addition is up to 9, it can be represented by single digit here. If the result of addition is more than 9, okay, or if it comes to 10, so this, for example, here it is 7 plus 8 is 15. It is more than 10. More than 9, so there is a carry here. So actually what I do, I take this, see I am taking this number again, 47 in base 10 plus 98 in base 10. How you add this in base 10, and try to understand this concept. This is what will apply in all addition. See, 7 plus 8 is 15, which is exceeding 9. It means what I do, I simply divide this 15 by the base of the number. Base of the number is 10. So 10 ones are 10 and remainder is 5. What I do, I write this remainder 5 here and this quotient is taken as a carry here. Now 9 plus 4 plus 1 is 13. This is 9 plus 4 plus 1 is 14. So 14 is again exceeding 9. So I divide this number 14 by 10. I say 10 ones are 10 and remainder is 4. This 1 is carry and I write this 4 here, and this is 145. This as a carry here. This one as a carry. This is how we do addition. Suppose I take another number. This is 888. Let's take like this. 888 and another number. Suppose I say it is 888. For simplicity, I'm taking like this. Of course, with base 10. Base 10. And this is also base 10. And suppose I say add this numbers. How we add this number? 8 plus 8 plus 8 is 24. 24 is more than 9. I divide this 24 by the base of the number 10. 10 to the 20 and remainder is 4. So what I do, I write this remainder here 4 and this 2 as carry. Now this will be 26. 26 again exceeds 9. I divide 26 by 10. Remainder will be 6 and quotient is carry. Again 26 8 plus 8 plus 8, 24 plus 2, 26, and this will be 2664 in base 10. This logic I'll apply in all sort of additions here. So I'll come with a problem. First I'll do octal addition, for example. I'm not writing as octal addition. Suppose I say that you add these numbers 432 in base 8, and I say that add 673. 673 is another number in base 8. Remember that one more point, if you want to do any mathematical operation among few numbers, all the numbers must have same base. It is not directly possible to add numbers with base 8 and base 7. How to do it, I'll discuss it later on. It can be done. Now, I ask you that add this. This is an example here. It's a simple example. How to add these numbers. This is an example here. Now, base 8 means we have numbers from 0 to 7. We have numbers from 0 to 7. If I want to add this, just see. Octal number means you have digits from 0 to 7. If the result of addition exceeds 7, there will be a carry. So 3 plus 2 is 5. Which is less than 7, I write this 5 here. Now 7 plus 3 is 10. What I am doing, addition in my mind is with respect to base 10 only. But 7 plus 3 is 10. 7 plus 3 is 10 is more than this. So what I do, I divide this number. Simply, I divide this number. 7 plus 3 will be 10. I divide this number by the base 8. By this base 8 here. 8 ones are 8. And remainder is 2. So it is very clear that I write this 2 here, and this 1 will be carry. This 1 will be carry here. This one I write here as a carry here. Now again I add this. 6 plus 4 is 10 and 10 plus 1 is 11. 11 is again more than 7. So what I do, I divide 11 by 8. I divide 11 by 8. 8 ones are 8. Remainder is 3. I write this remainder 3 here. I write this remainder 3 here, and this 1 will of course will be a carry. So this is the corresponding number in base 8, and this is my final answer. Let's take another example with base 8 only. That suppose I have a number, let's take some bigger number. Suppose I have a number, say 6, 7, 3, take 7, 2, 7, and there's another number, say 3, 4, 6. All these numbers are with base 8. All these numbers are with base 8, and I say add them. There's a problem. Another example. I say add these numbers. This is another example. Add this number with base 8. Now see, 7 plus 6 is 13, and 13 plus 3 is 16. 16 is more than 7. In octal I have digits up to 7 only. So I'll divide 16 by 8. I divide 16 by 8. I simply divide the 16. Addition of this is 16. So I divide the 16 by 8. 8 to the 16, and remainder is 0. So I write this remainder 0 here. I'm writing this remainder 0 here, and this 2 will be carry. This 2 is carry here. Okay, now I will not divide it. I will simply write it. Now, it is 7 plus 2, 9. 9 and 2, 11. 11 and 4, 15. If I divide 15 by 8, 15 ones are 15. Remainder is 7. So I write this remainder here as 7, and carry will 1. Now, again I add these 14 and 3. 14 plus 3, 17. 17 I divide by 8. 8 to the 16. 8 to the 16. If you see this here, 7 plus 7, 14, and this is 17. I divide this 17 by 8. So it is 8 to the 16, and remainder is 1. So I write this remainder here and 2 as carry. So it is 1, and this is 2 here. So this is my final result of addition of these three octal numbers in this way. Suppose, let's take another example. Let's take a binary addition. For example, suppose I say, what is a binary addition? Let's take another example. In binary, I have digits only from only 0 and 1. And suppose I say that add these numbers, binary numbers, 1, 1, 1, 1, and suppose I say 1, 0, 1, 1. I ask you to add these two numbers. Now in binary, you have digits only 0 and 1. These are the two numbers with base 2. And I say that add these two numbers. Now how will you add these two numbers? Of course, the calculation I do in my mind is decimal only. So 1 plus 1 is 2. But binary does not understand any digit as 2. So what I'll do? 1 plus 1 is 2. My result of addition in my mind is 2. I'll divide 2 by the base of the number 2. So what I am doing? I am dividing this 2 by 2. 2 ones are 2. Remainder is 0. So this is, I'll write here 0 and 1 will be carry here. So this is 0 and this 1 as carry. 1 carry. 1 plus 1 will be 0 and it is carry here. Now 1 plus 1 plus 1 is 3. I divide 3 by 2. Just see, I am writing here. I divide this 3 by 2. 2 ones are 2 and remainder is 1. I write this remainder 1 here and this carry 1 here. Again 1 plus 1 is 2. 2 is more than 1. I divide this 2 by 2. Remainder is 0 and quotient is 1 as a carry. 1 plus 1 plus 1 is 3. Again, as I did here, it is 1 with 1 here. So this is my final result. 1, 1, 1. Let's treat with a single kind of pen only. This is the result in base 2. Or even you can cross check the result. For example, how to cross check it? I'll say that this you do on your own. In all these problems, you convert this into base 10. What is the corresponding number in base 10? What is the corresponding number in base 10? Add these two numbers, you know decimal addition. You'll get another number in base 10 and see whether the result of this in base 2 is this much or no. It will be a revision of your conversion also. So this is how you add any binary number. Let's take an example of some hexadecimal number also. That suppose I say you add, let's take another example. That add two hexadecimal numbers. Suppose you say that I ask you to add any number, say 4A 5C. This is an hexadecimal, base 16, and I say add this with 9B F5. These are the two numbers in hexadecimal, means base 16. Now remember that in base 16, as per decimal, up to 15 in decimal can be represented by a single digit. A corresponds to 10, B is 11 and up to F is 15. I ask you to add these numbers. How will you add these numbers? The question is that. Now see, C means 12. Just see, I am interested in C plus 5. I'll do it here. This portion. I am interested in this portion to add this C plus 5. How I'll add this C plus 5 here? The C and this 5. See, I am interested in C plus 5. Let's talk about only this portion now. C plus 5. C plus 5. I know that C corresponds to 12 and 5 is as it is. So in other words, I have to do 12 plus 5. So 12 plus 5 is 17. 17 is more than 15. Had it been up to 15, had the result of addition been up to 15, I would have represented by a single digit F. But since it is more than 15, so what I do? I divide this 17. See, I divide this 17 by the base of the number, which is 16. So 16 ones are 16 and remainder is 1. I write this remainder 1 here. I am writing this remainder 1 here and this 1 as a carry. This particular 1 as a carry here. Now I have to add F5 and 1. Just see, I have to add this F5 and 1. F5 and 1. F corresponds to 15. 15, 5 and 1. This is I have to add here, and this results in 21. Again 21 is more than 15. So I divide this by the base of the number 16. It will be 16 1 ja 16 and remainder is 5. I write this 5 here and this as a carry. This quotient as a carry and remainder as a sum. So this is 5 and this 1 is carry here. It is carry. Now I have to add 1a and b. I have to add, I am showing here. This is 1a and b. I have to add this. 1 is 1 as it is. A corresponds to 10 and b corresponds to 11. If I add these, so it will be 22. Again, this 22 is more than 15. So I divide this 22. I divide this 22 by 16. So it will be 16 1 ja 16 and remainder is 6. I write this remainder 6 here and this 1 as a carry here. Now 9 plus 4 is 13 and 13 and plus 1 is 14. I cannot write 14. It is hexadecimal. Up to 15 can be represented by single digit. So if you see 9 plus 4 plus 1, 13 plus 1 is 14 and 14 is E. This 14 is E. So this is the corresponding result in base 16. I hope that this is clear to you. So first of all, remember that if I have to add any numbers or I have to do mathematical operation among some number system, the very first thing is that all the numbers must have same base. If they are not the same base, so I'll have to bring it in the same base. Let's take an example of this also. I'll take another example. That suppose I say that add two numbers with different bases. Suppose I say that you have a number, another example here. I say you have a number 653 and this is the number in base 8. Let's take. This is a number in base 8 plus. Suppose I say you have another number 7, B, C and F. This is in base 16. And I ask you that what is the result in base 16. Now this addition is directly not possible. I need the result in base 16, means both the numbers should have been base 16. So very first thing what I do, I convert this 653. My first target is to convert this 653 into base 16, base 8 into base 16, and I have told you how to convert a octal number into a hexadecimal number. So first look at the solution of this. I convert the 653. I'll go via base 2. 653 in base 8 is equal to, in base 2, if I have to convert this into base 2, this 8 is 2 to the power 3. So I'll represent every digit by 3 bits. It's a revision of the previous lecture. So it is 1 1 0. 5 is 1 0 1 and 3 is 0 1 1. This is the corresponding number in base 2. How to convert this into base 16? Now I'll convert this into base 16 now by converting first into base 2. So if I have to convert this, I am interested in that what is the corresponding number in base 16. So I'll have to make a group of 4 bits. So I make a group of 4 bits here. These 4 bits from right to left, 1, 2, 3 and 4. And of course, I'll insert 3 zeros here. I don't have a space, so I'm writing 3 zeros here. Of course, it will be 1 only. So the corresponding number of this is 1. This is, look at this number. This is 1010 from this point. 1010 is 10 and this 10 corresponds to A. This is 1011, 8, 4, 2, 1, 11. 11 is B. It means this is 1A B. means the corresponding this 6653 is equal to 1AB in base 16. So now my target is what? I have to add these two numbers 653, not 653, it is 1AB. My target is now 1AB plus this number 7B, C and F. Both are in base 16. So I'll add these two numbers. So it is 7 B C F plus 1 A and B. This is what I have to add. Okay, now again this F and B, I am interested in the addition of F and B first. How will I add these F and B? See, F and B means F corresponds to 15 and B corresponds to 11. Now F corresponds to this, I have to do these two addition. These two addition results in 26. 26 is more than 15. So again I divide this number by 16. It will be 16 ones are 16 and remainder is 10. I cannot write this 10 here. This 10 corresponds to A. So I'll write this remainder A here and this quotient 1 as carry. Now I have to add, after this I have to add this 1C and A. So 1C A. I have to add this. 1 is 1 as it is, C corresponds to 12 and A corresponds to 10. So this is 23, I suppose. 23 is again more than 16. So I divide this by 16. 16 ones are 16 and remainder is 7. So 16 ones are 16 and remainder is 7. I write this here. Okay. Now this B is 11, 12, 13 and 13 is D. And this is 7 as it is. So this is my final result in base 16. That is the addition of this and this in base 16 is equal to this much. This is my final answer. So this is how you do the addition of non-decimal numbers. First thing is that all the numbers must have same base. I'll stop it here. In the next lecture I'll start with the subtraction of these number systems. So thank you for the time being.